We already know that the derivative of sine of x is cos of x. And so from that, it follows that the integral of cos of x would be sine of x, plus c, of course. We also know that the derivative of cos of x is negative sine of x. And so from that, it follows that the integral of negative sine of x would be cos of x plus c. And therefore, the integral of sine of x would be negative cos of x plus c. But we do have situations where we have a linear function in there. Okay, and from that, that would modify this. Cos of ax plus b would be sine of ax plus b plus c, but we would have to divide by the derivative of that inner function a. Same here. Sine of ax plus b would be negative 1 over a cos ax plus b plus c. What I've seen people use to help them remember differentiation and integration of trig functions is this. So for differentiation, the derivative of sine of x would be cos of x. Derivative of cos of x is negative sine of x. The derivative of negative sine of x is negative cos of x. And the derivative of negative cos of x is sine of x. And integration works in reverse. So I have known people to use this quite effectively to remember these rules. So on to some examples, and you'll see that we're going to need to use integration by substitution in C and D, and I'll talk about why when we get to it. So for A, nice straightforward one to start with. We can rewrite that as 3 times the integral of sine of x dx. Going back to our new rules, the integral of sine of x is negative cos of x. So that would be negative 3 cos of x plus c. In B, we have to apply that more complicated rule because we have an ax plus b inside the brackets. So the integral of cos of 4x takes c. Integral of cos we know to be sine. And we would have to divide it by 1/4. Multiply it by 1/4. Right, now we're on to differentiation using integration by substitution, rather. So what we have in these is a situation where we are multiplying some function by the derivative of the internal function, or the inner function. Okay, so in this case, the inner function is e to the x. In this case, the inner function is 3x to the power of 4. Over here, the derivative of that inner function is e to the x. The derivative of 3x to the power of 4 is not quite x cubed, but it's definitely related. And that's why we have to use integration by substitution here. So for C, what we need to do, I don't like this g and g dash notation. Let's use u. U is e to the x, and therefore du dx would also be e to the x. That's u, the inner function. That's du dx, the derivative of the inner function. So we replace those in the integral. Du dx sine u. Du dx sine u. These cancel because we are integrating a derivative. And so we're left with the integral of sine of u with respect to u. Recall that the integral of sine is negative cos of u, and then we substitute back in with our u value. Alright, d. Start the same way. Let u equal 3x to the power 4. Therefore, du dx equals 12x cubed. Alright, we have an inner function, but we don't yet have what we've highlighted in yellow there. To get that, which is x cubed, I would need to divide by 12. And so I must do that on the other side. So 1/12 of the derivative of the inner function will give me x cubed. And that's what I can sub back into the integral. So we've got the integral of 1/12 du dx cos of u dx. So we're integrating cos. Remember, that's going to give us positive sine. So they're going to cancel, and we're going to be left with the integral of 1/12 of cos of u du, just rearranging it, which is 1/12 sine of u plus c, and we substitute back in for u.